All right, that concludes the series of speakers. We had a late start, but I would like to give everyone a chance to ask more questions. So if you'd stay around for a couple more minutes. So please come forward to the microphone or type it into the chat. It's one question. Okay, we have one question in the chat. She will take care of that. Can we turn on the microphone, the handhelds? Okay. All right, there you go.
Okay, we have a question from Dr. Paolucci to Steve. Could the rare VLT be a sampling artifact owing to the small sampling size, sometimes missing ilmenite?
Yes, it is a possibility. It's certainly easier to identify high TI basalts that are rich in ilmenite. So we didn't miss too many of those. It's possible, I don't know where to look. It's possible that there's more VLTs than we were able to identify. So yes, but they are rare. We've looked at lots of samples. They're not found among the hand samples. They're only found in small fragments.
Thank you.
All right, and we have one from the audience, please.
Yes, Nick Piskrich, University of Central Florida. I had a general question for the first two speakers. Do you view these instances or occurrences of the evolved silicic magmatism? Is it possible that those instances would have co-occurred with Mare basaltic magmatism? And what other pieces of evidence do you think you would need to confirm or support whether these different types of magmatism would have occurred at the same periods of time, or else there's a kind of a stark differentiation between the timelines of these two different types of magmatism?
Yeah, I think what we're at least examining right now to first differentiate the timescales over which Mare magmatism and the silica-rich magmas were erupted is, as I showed in several of the slides, we do have accessory minerals that were derived and crystallized from these belts because of their high incompatible element characteristics. And so therefore, the first step, which we're doing the beginning of next month, is using the nanosims to essentially date the zircons that will give us kind of an idea of, from the samples themselves, over what time period did they crystallize and were produced. Also, we have a variety of other approaches that we can use because there are issues with regards to the origin of these, as you know, whether this is a product of differentiation of a parent magma with high H2O in it, whether it's a product of liquid miscibility, or it's a secondary melting process of the lunar crust due to ponding. And I think each of those three models can be differentiated based on some of the measurements we're making. Yep.
I'll just add that those felt sites that Chip showed are somewhat complementary to the basalts that I showed. And we've also even found dunites. So it's a whole range, whole spectrum of lithologies, possibly related. And whether we can resolve the time differences remains to be seen as far as the time scale of as to how long that took. When you crystallize the lunar mantle, you'll first get very olivine-rich materials. The residual liquid will become richer and richer in silica. Eventually, you get the felsites that Chip showed. And hopefully, dating these materials can give us a better idea of the time frame of how long that took.
Thank you.
All right.
We have one more question from Brad Jolliffe to the VLT question. The XCD data for class from 70002 confirm some of the VLT basalt fragments large enough to see that the mineral assemblage is representative and does not include ilmenite. These larger rock fragments can be compared to the tiny ones found in the finer materials. It's a comment, I guess.
Yeah. Okay. More questions from the audience? look like it, and seems like the chat is all good. All right, well then, I'd like to another round of applause for our speakers. Thank you very much for giving us an update on these pristine Apollo 17 samples to learn more about the Taurus Little Valley and about the moon. So thank you very much.